Good morning, students. In yesterday's period, we had calculated the potential at a point due to the solid sphere, due to the solid at a point P inside a solid sphere of radius x. That equation is like this: minus 4 pi minus 4 pi minus 4 pi. That equation is minus 4 pi x square rho dx upon r. This is equation number 5. Up to this equation, we have derived this equation, and this equation is for the potential at a point. The point is lies inside the solid sphere. Now, and for this we have considered a sphere is made up of a hollow cells concentric to it, and now we are going to calculate the potential at each cell. Therefore, for now, the potential at a point P within a cell is the same as that as at any point on its surface. Therefore, we have to put x equals to r, or r equals to x. R equals to x. Therefore, this equation becomes minus 4 pi x square rho dx upon, instead of this r, we have to write here as a x into g into z. Here it is z and here g. Therefore, this x and will get cancelled with this. Now it is minus 4 pi x rho dx into g. Rho dx into g. This equation is equation number 6. By integrating this equation, what we are getting? We are getting the potential on, suppose this is that sphere, and we have considered this sphere is made up of hollow cells. Now, what we have done? We have calculated the potential due to this inner cell, and that point is like here. Now, by integrating this equation, what we are doing? We are calculating the potential due to all these cells. Therefore, integrating this equation, integrating this equation between integrating equation 6 between r to r. This r to r is the radii from the center core. This is the center core, and this radii is r, and this radii is capital. Means as we go away from the center, the radius goes on changing. This cell is having, suppose this inner cell is having radius r, then this cell is having radius other than this r, then this is other cell. In this way, to calculate the potential due to all these cells, we have to integrate this equation from r to r. Now, we can write that like this: integration from r to r minus 4 pi x rho dx into g. Here in this equation, this 4 pi and this g and rho is a constant. Therefore, these constants we take outside the integration sign. Therefore, minus 4 pi rho g integration from R to R x dx. Now, taking integration, if we integrate this, then we get here like this, we get minus 4 pi rho into g, its integration of this x is x square by 2 is raised to x square by 2 integration range from R to R. Now, solving this, minus 4 pi rho g into, putting this limit, upper limit and lower limit in place of x. Therefore, it is R square by 2 minus R square by R square by 2. Therefore, this is the potential due to all these things. This by this equation, integrating this equation, what we are getting? We are getting the potential due to all these things. There, and that we denote as a V2. It is suppose V2. It is suppose V2. Okay. Then this V2 can be written as V2 equals to 4 by 3 pi rho g into 3 into R square by R square by 2 minus R square by 2. Here one adjustment is made, and that adjustment is this 3. Means we have multiplied it and divided by 3 to this equation. You can write that here, multiply and divide by this is the arrangement, and therefore this equation becomes V2 equals to minus 4 by 3 pi rho g, multiplying this 3 to this bracket. Therefore, it will become 3r square upon 2 minus 3r square by 2. The total potential, therefore, now we can write the total potential. This is the potential due to the all cells, and we have calculated this formula. We have calculated the potential due to the inner solid sphere. Now, the total potential is the potential at point P due to the inner cell and potential at point P due to the all cells. That therefore we can write here total potential equals to total potential equal to potential at point P equal to potential at P due to solid sphere of radius r. Means this is the inner cell plus potential, the potential P due to all cells due to all cell. Therefore, that is, we can write that as like this: V equals to V1 plus V2. This V1 is the potential that we have calculated in yesterday's period, and this potential is at point P due to the inner cell, and this is the potential due to the potential at point due to the all cells. Therefore, we write that in this way. That can be written as V equals to minus 4 pi by 3 rho g 4 pi by rho g into r square minus 4 pi by 3 rho g into 3r square minus 3r square upon 2. Only we can write this. Now solving this equation or simplifying this equation, we get V equals to minus 4 pi by 3 into, means here this 4 pi by 3 rho z and rho g. We can take these quantities as a common. Therefore, the remaining quantities are here it is r square minus, here this bracket remains as it is, that is 3r square plus 3r square by 2. Here we write this 2 and this 2 like this also. 3r square by 2 plus 3r square by multiply by this minus sign to this bracket. Therefore, now again we can write minus 4 pi by 3 rho into z into the bracket, taking LCM 2r square minus 3r square plus 3r square. Here we are multiplying this minus sign, therefore this becomes minus and this minus, this minus and this becomes plus. This is minus and this is also minus. Both the things are minus. This minus plus. This is minus. Therefore, here V equals to minus 4 pi by 3 into rho into z. Here 3r square minus r square by this 3r minus 2r plus 2r, we are getting minus r square. Therefore, V equals to minus 4 pi by 3 into rho g, 4 pi by 3 into rho g, 3r square upon r, 3r square minus r square upon 2. Divide, multiply and divide by, multiply and divide by, multiply and divide by r we get. Therefore, we are getting here P equals to minus 4 pi by 3 rho z into r, as we have multiplied by this r cube, and into the bracket 3r square minus r square upon, here is only 2 but we are writing 2r cube as this r and this r. Here this r is multiplied to the numerator and this r is written in the denominator. Means there is no difference between this original equation. We can write like this. Therefore, this is just adjustment. Here, therefore, we can write this adjustment. After doing this adjustment, we can write the equation like this: minus 4 pi by 3 into rho into g into r cube into the bracket 3r square minus r square divided by 2r cube. Okay. Therefore, lastly, but 4 pi by 3 r cube rho 4 pi by 3 r cube rho is nothing but the mass of the solid sphere. This is the mass of the solid sphere that we already previously considered this sphere. With this formula, we are getting the mass of solid sphere. Therefore, we put this m in place of this. Therefore, minus 4 mg minus mg into the bracket 3r square minus r square divided by 2r, and this is nothing but the total potential. This is the equation for total potential due to a solid sphere at a point which can be written as v equals to minus mg into the bracket 3r square minus r square upon 2r. With this, we have calculated the potential at a point due to a solid sphere. The point is lying inside the solid sphere.